Hi there. So today we're going to talk about how to calculate forecast value add. I think it's a concept that has been around for some time, but I think there's a lot of people who is interested about the topic. They're learning about how to implement forecast value add in their organization. So hopefully I can bring some insights today for you. So when you think about the typical forecasting, demand forecasting cycle, you have different steps in that process, right? You don't need, by the way, to have all these steps that I'm mentioning here, but the typical demand planning process, when you think about an organization, a manufacturing company, or a company that produces products or ship products to customers, so you got to think about like different steps that you go through your demand planning process. What I'm going to describe here, as I said, is like a standard process that some companies follow all the steps, but some companies just have one or two of those steps currently. So step number one is what is called the baseline forecast. So we call it here naive baseline forecast. Let me give you a couple of examples of what a naive baseline forecast is. So think about when you are projecting your sales for the next month. Maybe one option that you have is just to assume that the sales for next month are going to be the same as last year. So that's very straightforward. So you just take the sales of your last year and then you just project those sales for next month. Maybe you're taking a moving average. You're saying, hey, I'm going to take the moving average for the last 3 months or the last 6 months. I'm going to use that average and project that as the forecast for next month. Maybe you are using like, a very simple method, whatever that method is, but essentially that's what we call a naive baseline forecast. So that's some organizations run that process on a monthly basis, on a monthly cycle, so they have that naive forecast established. So maybe the step number two in your process is that once you have that naive forecast established, maybe you have a software tool, maybe you have a statistical model, maybe you're using an advanced planning software, whatever you're using, but sometimes, well, companies create what is called the statistical forecast. So it could be as elaborated as time series models using ARIMA or exponential smoothing, or it could be as like elaborated as a machine learning algorithm that someone in your team put together. But regardless of the method, I mean, the step number two in your forecasting process or demand planning process typically is like you get that statistical process or forecast in place. Step number three maybe is that you have planners and you are taking that statistical forecast and then touching the forecast and making some adjustments. So essentially the statistical model is saying you, hey, 100 units for next month, but then the planner, he wants to override that forecast and then put it down to 95 or increase it based on some information that he has or she has that it hasn't been captured in the statistical modeling. So that's kind of the typical step number three in that process, where the planner overrides or adds new information to the forecast to come up with a different number. Then maybe there's step number four in your process, where now the planner consults with sales and marketing and then brings additional inputs about promotional campaigns or product launches or any additional market intelligence that the planner is able to collect from sales and marketing. And maybe he's also or she's also making changes to the forecast based on those inputs that were not actually reflected in the statistical forecast or in additional information that the planner had before collecting those information from sales and marketing. So that could be a step number four in your process. So when you think about it, again, you don't need to have all of those steps in your existing process, but some organizations have this established first their naive baseline forecast, then they run their statistical modeling based on a tool that they may have. Then you have the planner overriding some of those forecasts. Then you have marketing and sales also touching the forecast, and then you come up with what is the outcome of this process, which is the final demand forecast that you are typically uploading into the ERP, the MRP, or your planning software. Now let's run through some exercise with numbers. So the reason why I'm just bringing this up is because I like peanut butter, right? So I got nothing to do with this company, no relationship at all, but I just like peanut butter. So we're gonna run an exercise with peanut butter. So think about that you're forecasting peanut butter, right? So and therefore let's go through the steps that we just described, but now with numbers. So let's say the first step is that we run a so we captured like the sales from last month or last year, and we assumed, okay, next month we're gonna use the same number. So okay, let's say the naive forecast for peanut butter in this case is 95 units. Now we have a statistical model, or we have a platform, more sophisticated platform that provides with a baseline forecast based on statistics and running like trends and analyzing trends and analyzing like modeling and trying to find the best fit, or the best model that fits to your demand. So statistical patterns. So let's say that this forecasting engine is suggesting us to that the forecast for next month or next quarter should be 110 units instead of 95. Now, let's say I'm the planner and I'm not that confident around the 110. I'm not confident around 95. I believe that it should be something in between the 95 and the 110. So maybe I'm thinking that the statistical model using some information that needs to be updated, maybe it's not catching up with the latest trends so fast. So therefore, I'm gonna override. So what's the statistical model said, and I'm gonna say it is the override is 105 units. Now I'm sitting with all these arguments and this information. I'm running my monthly cycle. Now I'm sitting with sales and marketing, the person who is in charge of like the sales of peanut butter in the market, and I'm bringing in all of those insights in regards to, hey, are there new listings or new things, new promotions that we're running that they're not actually repeating from the history, and therefore those may change our forecast moving forward. So in this case, I mean, typically sales and marketing people are quite optimistic about the future. So in this case, I'm just following that as an example, but capturing those sales and marketing inputs, these people said, oh, 120 units should be more like connected to what we are expecting to sell because of promotion X, promotion Y that it wasn't in the forecast, or potentially because of some additional reasons that we can document and have an assumption built in that is going to say 120 units in our forecast. And then let's assume that after all of this process, like conversation between the planner, looking at the numbers, showing like the forecast accuracy from last month, and then capturing the inputs from sales, marketing, etc., we all came up with like the consensus or the plan that we're going to sell 110 units as a final demand forecast for the future, and that's the number that we are going to come up with, and it's going to be the one that's going to be sort of uploaded into MRP, ERP to run our supply chain requirements. Now, we closed the month, we got the forecast or the cycle or the quarter or whatever that is. I mean, our 110 projection actually came in lower. So actually we received actual orders for peanut butter for 100 units. So instead of 110 that we forecasted, so we received units for 100. So that's how the typical cycle goes, right? So you got people touching the forecast or proposing ideas on how to come up with the final forecast, and then we got the actual orders and when we compare. So let's talk about now forecast value add. So how forecast value add is a metric that helps you assess and root cause the main deviations of the forecast, and who is or what are the steps that are adding more or less value to the final outcome, which is actually achieving the highest possible accuracy or reduced bias to help us drive supply chain efficiencies and drive our efficiencies forward. So I'm going to just discuss here a few steps on how you should calculate or use to calculate the forecast value add. But the more important things, I'm using the numbers just to illustrate the process, the framework, what steps you should take. So the step number one is that you need to calculate the unit error at each step of the forecasting process. And the formula that you typically use is that you take the forecast in units and you subtract the actual sales order. So in this case, you got to think about, like, you remember we forecast, there's various people within the process forecasting different numbers. So in this case, our naive, if I compare the naive forecast was 95 units, minus the 100 units that came as actual sales orders, so that's why it's -5. Then you got the statistical forecast. The statistical forecast was 110 units, so then 110 minus 100, it gives you +10. So then you got the planner override. The planner was forecasting 105. with their overrides. So then, so minus 100, it gives you 5. Then sales inputs and marketing inputs drove this idea of, oh, you should forecast 120, and then 120 minus 100 is 20, and then final demand forecast, the one that we all consensed and we put in our system, it was 110. So 110 minus 100, it gives you plus 10. So the error of each of the steps in the process is highlighted here. Is a total error. Now, the second step in the calculation of forecast value add is now you have to calculate the absolute value of the unit error and divide it by the actual sales orders in units. So in this case, the percentage error is the ones that you see here. So you have to take the absolute value of the unit error that we calculated in the previous slide, and then you divide it by the actual sales orders, in this example divided by 100. So that's why it gives you 5%, 10%, 5%, 20%, and 10%. So those are the errors that each of the steps in the process created as compared to the final orders that we received. Now, the next step in this process is quite straightforward. Step number 3, then you calculate forecast accuracy as 1 minus the percentage error. So in this case, it's 1 minus 5%, it gives you 95%. So naive baseline forecast, if we were to use the naive baseline forecast for projecting our sales, so the forecast accuracy of that naive forecast was 95%. So then you got statistical forecast 90%, planning override 95%, marketing and sales override, it was 80% accurate, and then the final demand forecast was 90% accurate. So therefore now when you think about like the addition of subtraction of value in each of the steps in the process, then you can see that, for instance, and that's the concept where we will now start thinking about forecast value add. So forecast value add essentially is the difference in forecast accuracies at each step. So if you remember, so the first line, so the naive baseline forecast was 95% accurate in terms of like the measurement, the metric. Now 95% accurate, but then the statistical forecast was 90% accurate. So it actually, the statistical forecast reduced 5 points of accuracy versus the previous step, which was the naive baseline forecast. So therefore, the value added or subtracted by the statistical forecast was the difference between 95% and 90%, which is essentially the 5% value subtraction in this case, not addition. Now, if you go to the next step, so from the 95%, or sorry, from the 90% that the statistical forecast was showing as metric for forecast accuracy, so the planner override, actually the changes or the overrides that the planner did improved 5 points the accuracy of the plan as compared to the statistical forecast. So in this case, the planner added value to the process because it improved our accuracy by 5 percentage points. Now, when you think about marketing and sales, if we were to pick only marketing and sales inputs to create our final plan, so we would have created an error of 15% more than like what the planner, the accuracy that the planner achieved. So therefore, in this case, again, following this example, right? So marketing and sales subtracted value out of the forecast by 15 points, right? Minus 15%. And then at the end of this process, when the planner actually considered the inputs from sales, marketing, and then factor all things and whatever, so the team who actually put that forecast or this plan together, so they came up with a consensus forecast or final forecast at, that it was like actually improved our accuracy by 10% points, because at the end of the day, again, if we were to go to the marketing and sales step of the process, it was 120 units versus 100 that we received, so that would have been a 20% error. And then in the case of the final forecast, we went with 110 versus the 100 that we actually received in orders, so that explains the gap of 10%. So this is a way for you to understand that essentially at the end of the day, what is important about forecast value add is that we are using a metric to help us deep dive into the reasons why our accuracy went higher or lower. What are the areas in this process or steps in this process that are adding or subtracting value in this example? Of course, for every product, it is going to be something different, right? But the important thing here is that is a mindset. It's a continuous improvement mindset that you try to implement in the organization by always measuring and tracking value added in the process, how your planners or your sales and marketing people or your statistical forecast engine is adding or subtracting value to your process, so you can think about now in the future more strategically around what are the items, what are the products, what are the things that we definitely need more input from marketing and sales, what are the things that we don't necessarily need to touch the statistical baseline forecast because we don't do a great job in creating value added in that aspect. So it allows you to diagnose where the areas for improvement are and potentially taking action, more strategic action moving forward. So connected to what you just said, so FVA essentially is a powerful continuous improvement tool that helps you identify opportunities for process optimization. So when you think about your demand planning process, where there's areas for improvement, optimization, and also increased productivity, so you don't waste your time in things that are not adding value. So enable us to learn from past mistakes. Think about like if we document all of those things and the steps moving forward, so we're going to start learning about the areas of this process that actually again are subtracting or adding value to the final goal, which is essentially trying to add value to the business by forecasting and projecting our sales in an appropriately in terms of like our future demand. And then finally, I think this is one advice, but the FBA combined with a segmentation analysis, that means looking at your entire portfolio and clustering, your SKUs depending on different patterns, demand patterns. So those two things combined, so FBA, forecast value add, as a metric combined with a segmentation analysis is going to give you a great way to define forecasting strategies if you are a planner, if you're a head of demand planning, or if you're a supply chain executive and demand planning resides under your organization. So therefore, I think combining those two techniques, so using FBA as a key metric in your process, plus using also some segmentation analysis or clustering of your SKUs, those two things combined are going to give you a lot of insights around the strategies that you should follow for improving your accuracy moving forward. Well, that was the idea of this video. The idea was to show you a little bit of insight on how the forecast value add process goes. What are the things that you should do? What are the things that you should avoid? What are some of the techniques? And I try to make it simple in terms of a very concrete example with numbers on how the different steps of the forecast value add process get calculated. And so connect with me if you need more insights, if you need more advice on how to make it operational for your organization. I'll be happy to help. Thank you very much and have a great day.